Okay guys, so we're going to finish up density dependent limiting factors first, and then we'll go on. So another density dependent factor would be herbivory, and this is going to work a little bit like the wolf and the moose populations did. And if you recall, I talked in class about how the wolf and the moose populations are constantly going up and down in response to each other. Well, again, it's going to be similar with the moose and the balsam fir population. Moose really like to eat that balsam fir on Isle Royale, so when the moose population is big, then the balsam fir population is going to go down because they're getting eaten by the moose. Once the balsam fir population goes down, then the moose have now run out of food and they're going to start starving to death, and their population is going to go down as well. And then I'm sure you can guess what happens. Once the moose population goes down, that gives the balsam fir an opportunity to restore their numbers and literally grow back again. And so once that balsam fir population grows back, in other words, once the food grows back, then the moose can start eating well again and their numbers will go up. And again, it's the same pattern of up and down that we saw with the moose and the wolves before. So go ahead and get your blanks here. If you need to pause the video, go ahead and pause it. But I'm going to go on to the next density dependent limiting factor, which is parasitism and disease. And I think we all, for the most part, can understand that parasites and disease-causing organisms feed at the expense of their host. And so what they do is they weaken the host, or they cause stress or death, depending on what the disease or the parasite is. But here's an example of, this is a hedgehog, by the way, and these white gross things are engorged ticks. They're full of the hedgehog's blood and they look like they're ready to pop. So the ticks on the hedgehog in the photo, for example, they feed on the hedgehog's blood. They probably carry disease. And so parasitism and disease are density dependent effects, because the denser the host population, the more easily parasites can spread from one host to another. And I want to remind you real quick of the wolf population on Isle Royale. In 1980, there was that outbreak of CPV, or canine parvovirus, that I told you about. And so at the time, the virus was accidentally introduced and it ended up killing all but 13 wolves on the island, 3 of them being female. So this drop in the wolf population, it gave the moose population a chance to just skyrocket to 2,400 moose. So those densely packed moose then became infested themselves with winter ticks, and that caused hair loss and weakness amongst the moose. So overcrowding can lead to also increased stress within a population. And some species, if they're overcrowded, they'll fight amongst themselves, obviously, because they're trying to fight for space or resources. And too much fighting it does cause stress, and it does weaken an organism's body and ability to resist disease. And in some species, overcrowding stress can cause females to neglect or kill or even eat their own offspring sometimes. So that would also contribute to lower birth rates, aside from just raising the death rate. And sometimes it'll cause individuals to emigrate or leave the population because they're looking for more resources, particularly space, since they're overcrowded. Excuse me. All right. And then finally we come to density independent factors. The two really good examples of density independent factors would be unusual weather and natural disaster. And so these are going to affect all populations regardless of the population's size or density. And that's why they're called density independent factors. Environmental change, like maybe hurricanes, droughts, floods, natural disasters like wildfires, can act as density independent limiting factors. In response to these types of factors, a population might crash down because a lot of individuals will be killed. So the population could possibly build up quickly again if they're able to find resources right away, or it might take a long time for them to rebuild if they're not able to find resources again. But again, these are factors that are going to hit a population, and it doesn't matter how big the population is or how densely crowded the population is. One little hint for remembering what density independent factors are: if the limiting factor is abiotic, then it's probably safe to assume that it's density independent, right? So here's again just examples of density independent factors: hurricanes, droughts, floods, wildfires. I'm sure you could think of more on your own. In events such as storms, storms can sometimes extinguish like local populations of some species. So for example, like thrips, aphids, and maybe other leaf-eating insects can be washed out by a heavy rainstorm. Waves that are whipped up by hurricanes can sometimes devastate like shallow coral reefs because they're very sensitive. Or extreme cold or extreme hot weather can also take a toll, no matter how sparse or how dense a population is. More prolonged environmental changes like severe drought can devastate populations. These kinds of environmental changes can affect ecosystem stability. So there's your density independent limiting factors. Let's take a quick little review here just to keep you on your toes there. All right, so here are some examples. Floodwaters that cover a field of wildflowers would be a density independent limiting factor because and then there's your clue here, floodwaters are abiotic. So that's your shortcut way. Non-native snakes released into a wetland prey on native rodents. Snakes are biotic, so you can assume that would be a density dependent limiting factor. Flu virus spreads quickly in schools. Viruses are not living. However, I did say that there's always a few exceptions. Viruses are disease causing, so those go under density dependent limiting factors. So that might be a little bit confusing, but viruses go under density dependent limiting factors. Wildfires spread through a grassland. Wildfires are not alive, they're abiotic. So wildfires that spread through a grassland would be a density independent limiting factor. If you have any questions or you're confused about anything, you might want to write that down right away so you don't forget to ask when you see me later. But as far as section 2 goes, that's it for now. Again, let me know if you have any questions or you were confused about something. Thanks.